Okay, today we're working in lesson 1 of module 7.6. I know it's kind of out of order, but it fits with what we're working on. First part of it is going over a lot of definitions, making sure you remember what these words mean. Many of them are words you've already been taught, but there will be a couple that are new to you. In the first term, two angles, angles AOC and angle COB, with a common side of ray OC, are adjacent angles if C is in the interior of angle AOB. So I've drawn a picture for you, the one in blue and one I'm showing you. They share that ray OC, and so adjacent by definition means side by side. Those two angles are beside each other and they share a ray. So if you have two angles that are next to each other and they share a ray, they are called adjacent. Second definition, when two lines intersect, any two non-adjacent angles formed by those lines are called vertical angles or vertically opposite angles. The picture I've drawn for you up at the top with the purple lines, the two angles shaded in purple are vertical angles. The two shaded in the green are also vertical angles. Vertical angles will have the exact same measurement. They are congruent. The third one, two lines are perpendicular if they intersect at one point, and any of the angles formed by the intersection of the lines is 90 degrees. Two segments or rays are perpendicular if the lines containing them are perpendicular lines. And so I've shown a picture right underneath that. You have two lines where they intersected at that point, right there. They formed right angles, and because they formed right angles, they are called perpendicular. Okay, it's asking us to complete some information in the table below just to help with your understanding. When referring to adjacent angles, sometimes people will use the abbreviation angles, so the angle symbol plus an S, and then ADD for adjacent angles. And adjacent angles, if you look at the picture, angle A plus angle B is equivalent or equal to angle C. So angle A, right there, angle B combine to make angle C, because angles A and B share a ray. Okay? Vertical angles, the abbreviation for that one, when people are trying to shorten up, vert angle symbol followed by the S, angles. And in that, angle A is equal to angle B. So the measurement of this angle is going to be equal to that angle because they're opposite. The same is true, this one over here is going to be equal to this one over here. Okay, going on to the next page. Okay, angles on a line, shortening that up, angles on a line. If the vertex of a ray, so the vertex is this point right here, center of the angle, lies on a line, but the ray is not continued in that line, then the sum of the two measurements of the two angles formed is 180. And so that's our supplementary angles. So A plus B equals 180 because they formed the straight line here. Okay? So combining them. Okay? So that is our supplementary angles. Angles at a point. So angles at a point. And it says, suppose three or more rays with the same vertex separate the plane into angles with disjointed interiors. Then the sum of all the measurements of the angles is 360. So A plus B plus C equals 360. So think of your circle. Okay, so angle A, angle B, and angle C all combine to make a circle, and those have to add up to 360. Okay, down here at the bottom, just a review of complementary and supplementary angles. Whoops, thought I had my pencil there. So must add up to 90, and we've done this earlier in the year, and supplementary angles must add up to 180. Now, often you find them touching like they do in the top picture in each box, but please understand that they can be two separate angles in two different places and still be considered complementary or supplementary. If their sum adds up to 90, they're complementary no matter where they're at. And if their sum adds up to 180, they're supplementary no matter where they're at. Okay, number 1 says, in a complete sentence, describe the relevant angle relationship in the diagram. Write an equation for the angle relationship shown in the figure and solve for x. Confirm your answer by measuring the angle with a protractor. So you probably don't have a protractor, so you're probably not going to be able to do that last part. But when you look at the picture, you need to see where angle x is. And notice angle x goes from here to here. So angle x, see where that curved line is this whole area. It is not just one part of that, okay? It refers to this line right here. And so when I look at angle x in comparison with this angle over here, I notice that the two of them together form this straight line. So when I go to describe, it says write a complete sentence. I can say that the angles x and 22 are supplementary. When I set up an equation to solve that, x plus 22 equals 180. Subtract 22 from both sides, and x equals 158 degrees. So one of the keys here is they are asking you to be able to write the equation, so being able to set this up. When you set it up, remember we're not putting a variable by itself like we reviewed in yesterday's lesson, so you are not to write 180 minus 22 equals x. That is not the type of equation that they're wanting you to learn to set up. All right, moving on to example 1. The measure of two supplementary angles are in the ratio of 2 to 3. Find the measurements of the two angles. So we've done this before. So there's two angles, and they are supplementary. They are in the ratio of 2 to 3. So my smaller angle is 2x, my larger angle is 3x. So 2x plus 3x equals 180 because they're supplementary. 5x equals 180. And so when we divide both sides by 5, x is equal to 36. Okay, so then I come over here to my picture because I've got to find the measurements of the two. So 3x equals 3 times 36, and that equals 108 degrees. And 2x equals 2 times 36, which is 72 degrees. 108 plus 72, if I add those up to check, I get 180. In number 2, a pair of complementary angles. So I've got two angles that have to add up to 90. So I'm going to just split right here. And it says the measurement of the large angle is 3 times that of the smaller angle. So if I make the smaller angle x, that means the larger one is 3 times x. Find the measurements of the two angles. So 3x plus x equals 90. 4x equals 90. So x equals 22 and 5/10 degrees. So angle x is 22 and 5/10 degrees, and the larger angle, 3x, is 3 times 22 and 5/10, and so that gives us 67 and 5/10 degrees. Okay, number 3, the measurement of a supplement of an angle is 6 more than twice the measure of the angle. Find the measure of the two angles. So supplementary. Draw my two angles that form a straight line. Okay, so we've got one angle is x and the other one is 6 more, so 6 plus twice the measurement, so twice the other one. So 6 plus 2x. Now altogether they add up to 180. So 6 plus 2x plus x equals 180. So I have two terms here that I can combine. And so 6 plus 3x equals 180. Subtract 6 from both sides. 3x equals 174. Divide both sides by 3. And when I do that, x equals 58. So this angle right here is 58 degrees. And the other one, 6 plus 2x, so I'm going to plug in 58 for x. So 6 plus 2 times 58. So I'm going to calculate that, and when I do, I get 122 degrees. Okay, number 4 says the measure of a complement of an angle is 32 more than 3 times the angle. Find the measurement of the two angles. So our two angles are complementary, meaning they add up to 90. So we split that into 2, and so we have our first angle, and then the second one is 32 more, so we're adding 3 times the first angle. So now we want to write that in an equation. 32 plus 3x plus x equals 90. So I can combine the two terms with x's. So 32 plus 4x equals 90. I'm going to subtract 32 from both sides. So 4x equals 58. Divide by 4. And then x is equal to 14.5 or 14 5/10. So this angle is 14 5/10 degrees. So the other one, 32 plus 3 times x. So 32 plus 3 times 14 5/10. So I'd use my calculator at that point to get my total, and it is 75 5/10. So 75 5/10 degrees. And then I could check by adding that to 14 5/10 and making sure that we get 90. Hi, on example 2, it says two lines meet up at a point that is also the vertex of an angle. Set up and solve an appropriate equation for x and for y. Alright, so when I look at this one, for x, I can see that angle x and angle y are 180, but I don't know what either one of those is, so I'm going to have to see if I can solve for y first. So I can see by looking at this picture that angle y plus the 16-degree angle together have that right angle symbol, so that combines them. So I know that y plus 16 equals 90. So I'm going to subtract 16 from both sides. And so y equals 74 degrees. So this one is 74 degrees. Now, as I said before, I could see that x and y together made a straight line. So that's this line right here. And angle x is from here to here. And then y is the 74 degrees. So x plus 74 equals 180. Subtract 74 from both sides. And x equals 106 degrees. So now I've solved for both of those angles. Okay, remember as you continue working and you go to solve the problems on the problem set, it is not just about finding the answer, but it is about can you set up an equation that does not set it up where your variable is the answer. For example, on example 2 that we just did, we do not want to write 90 minus 16 equals y. That is not how you set up an equation, because an equation is something that you're solving by balancing sides, and you don't have to balance sides for that.